Hello everyone, how are you all? Yeah, so if you guys can hear me, can please let me know in the chat. Hello Niranjan, how are you? So guys, we are meeting over here. As you guys know, we have been running the series of the analysis of the CBSE sample papers which have been released recently. So the analysis of the chemistry, biology and math paper is already there. You can find it in our YouTube channel. And here we are doing the analysis of the last subject, that is physics today. And if you want to see like where you would find all these sample papers, I suggest that you go to the CBSE's official website, cbseacademic.nic.in. Over there, when you go to the sample question paper section, there for the current year, 2022-23, you can go to class 12th, and there you would find the sample question paper for all the subjects that you have. Particularly today, we are going to talk about physics, for which sample question paper you can find here, and its solution and everything you can find here. So coming to the main thing, like we have discussed about chemistry, biology, mathematics, you have gone through the analysis, you have seen how much it is similar to the previous year papers and how much difference is there in this paper. So let me present it for physics also. So let's open the physics paper. So you can find it over here. There's a sample question paper of physics. So guys, as you can see, the marks as usually it is of 70 marks again, and it's a 3-hour paper. So the overall pattern has the pattern of the paper has not changed. Of course, the distribution is different a little bit because of COVID in the past couple of years. The pattern had been changing. In fact, in years like in the previous years, you had seen a new thing called term 1, term 2 also, but this time it is like the normal situation. So here we are having a 70 mark theory paper this time, and a 30 mark will be calculated on the basis of practicals and internals and everything. So if we look at the overall pattern of this, the general instructions, so there are 35 questions in all, as you can see. Then there are like 5 sections in which it has been distributed. You see the same thing has been there in other subjects also. So there are MCQ questions also, as you saw in chemistry. Kajal ma'am had discussed it in the last video, where like she mentioned like how MCQ questions can be like very scoring for you to solve. Although like there are 1 mark each, but you do not like, it saves you a lot of time, because in MCQ you don't need to show all of your work. Just 1 mark, only the answer needs to be given. So if you give your working, well and good, that will be like additionally a bonus score probably, but it's not going to be very important to solve each of them and show the whole math. You can just write the answer, that also will do. So 1 mark question, 18 such questions, so 18 marks straight you get for MCQs. Then there are 7 questions of 2 marks each in section B. In section C you have 5 questions of 3 marks each. Section D, 3 long questions you have, and which each of them is of 5 marks. So that is going to be the heaviest section in the entire paper. And then lastly, in section E, you have 2 case study based questions. So people have complained a lot over the past years, like those who have been giving boards in 10th or 12th, they every time say like case study questions are what we have most doubt in. We don't know what kind of questions they can ask. So let me give you a small tip. In case study based questions, question is not out of the syllabus. I don't know why we are so afraid about case study based questions. If you have noticed past year papers, which you will, of course, after this video, you can check what kind of questions have been asked in the case study. You have already studied a number of chapters till now in physics, chemistry, mathematics, biology. So you will be able to see the kind of case study based questions they ask from there. So it's not like completely out of syllabus. It's just that they give a paragraph, and there are 2-3 parts in that. So out of, if there are 3 to 4 parts, 2 to 3 parts itself will be questions from the syllabus, mostly like for which you don't even need to read the passage. You don't need to read the case. One question is there which, by using simple logic, you can still get the answer of. So that is what section E type of questions are. You don't need to worry a lot about it. Of course, we can expect, like you can see guys, there are also some extra practice questions and question bank present over here in the CBSE's website. So if you need, you can go through them also before the exam. Then I'm sure you must be practicing a number of other reference books also you are going to practice through to get the idea. So my point is, don't be a lot worried about case-based questions. If you understand the chapter, it's case study based questions also you can solve. So we are going to see over here what is the basic difficulty level of the question, also questions we are going to check compared to earlier years. Then we are also going to see what kind of questions they have asked, because I know in physics the most doubt that we have is, are numerical questions having more weightage or conceptual? And what about derivations? How many derivations should we prepare? So there is a group of people who is a little afraid about solving the numerical problems. Some are not good at remembering conceptual type of answers, like the theory type of answers. So I'm going to tell you what is the weightage of all these, which chapters they have mostly asked these questions from, etc. So let us start with the detailed analysis. Um, so let me share my screen with you for the paper where I'm going to show you all this work. Hmm. So look at this. This, as I discussed, is the paper. Um, so you know the kind of chapters that we have in grade 12th, all the chapters you must have already studied. And you must know, like communication chapters has not been included in the CBSE's uh, syllabus this year. The communication, the last chapter. Like you can find it again on the official website of CBSE. So you can over here check the syllabus from the curriculum section. So curriculum 2022-23, you can find the syllabus for each of the subject of, be it of grade 10th, be it of grade 12th. You can check over there. So for example, in this, you can go to academic electives. In physics section, you can go. So there you will be able to find what all topics, subtopics are there. Okay. So here, when you scroll down, you will be able to see what topics, subtopics are, will questions be expected from. Okay, so let's come back to the question wise analysis that we have. So firstly, let me give you a basic idea of the distribution of marks from different subjects, different chapters in physics. So first of all, you have the chapter called electric field, electrostatics, electric fields, electric forces. Then after that, you have the concept of the chapter of electrostatic potential and capacitance. So I'm going to give you a little uh, like a different distribution of electrostatic potential and of capacitance. Although like they have been clubbed by CBSE in a single chapter, but I believe there's a significant difference in when it comes to kind of the questions they ask in exams. So I have distributed into two categories. Then after that you have current electricity chapter. Fortunately, potentiometer part like has not been mentioned in the CBSE uh, syllabus, and you will not be able to see any questions of potentiometer in this paper also. So that could be a relief for some of us who are not very strong at this topic. So that we are not expecting any questions from there this year. Then after that, we have the chapter of magnetic, basically moving charges and magnetism. Magnetism can be like has been divided into two parts: moving charges and magnetism, basically including the Ampere's law, and then magnetic field due to wire and all that stuff. And then there's magnetism and matter. Magnetism and matter. And then you have the chapter electromagnetic induction, one of the longest chapters that you must have studied. And in this electromagnetic induction itself, there's a part of alternating current, AC current. So this also is has turned out to be like decently important in this paper. We are going to see how much detail it is being taken in. Electromagnetic waves. Yeah, this is a theoretical chapter if you have seen. And from this also a couple of questions have been asked. So we will see what kind of questions have been asked. Then after that, we have optics. Optics is of like ray optics and then wave optics. So just listing out the chapters that have been included. And then I'm going to give you the distribution also. You have photoelectric effect, basically dual nature of matter, photoelectric effect. And then you have atomic physics, the last part, the modern physics part. Atomic physics, mostly like the grade 11th chemistry atomic structure chapter. And then you have nuclear physics. This is going to be a little new for you. And then semiconductors. I think by now, like we are having this video in October month, so you must not have studied these chapters by now, most probably. But when you will study it later on, you will realize that it's not that difficult. Mostly all these chapters are theoretical. Again, we will see what kind of numerical questions also have been asked. But yeah, these are mostly all the chapters. And if I talk about the most highly weighted chapters. So that is basically the first one, electric field. Here, 8 marks in total. 8 marks of questions have been asked in total. And this the second most important is ray optics. Ray optics also 8 marks of questions have been asked from this. Then after that, second most important is semiconductor physics, which we have not even started with right now in schools, which is of 7 marks in total. And then third highly weighted chapters are current electricity, 6 mark, then wave optics, 6 mark, and then atomic physics, 6 mark. So if you are almost halfway done through your syllabus in school, then you guys already know that the most important topics, which questions can be expected to ask from in school exam, in board exam this year, are actually from the upcoming topics. So this is high time that now onwards, if we are in the midway of the syllabus, we are very much, we ensure that the rest of the topics we understand very properly. Those are the most highly weighted. Others also are important. There are more number of chapters, but each one of them have little lesser marks, lesser weightage, mostly 3, 4 on an average. But the most highly weighted chapters are still to come. So let's make sure in the next couple of months, we prepare for them very, very properly. Now, these are the most highly weighted chapter. Now your next question would be, what about the conceptual questions, numerical questions, and derivations? So these are the three kind of questions: conceptual question, numerical questions, and derivations. Now a big relief to those who do not like derivations, do not like remembering derivations. Although like if you understand derivations are very easy to do. Like in my time, I definitely used to believe derivations were more scoring. But it's a good news for those who are not good at derivations, because in total only 8 to 10 marks of derivations were asked. I say 8 to 10 because of course there were options, internal choices between the questions. So depends if you want to go for them or not. So out of 70 marks in total, only 8 to 10 marks of derivations. So derivations are having lowest weightage in this sample paper, and we can expect the same in final one also. Or the same with you, Niranjan, fine. And then guys, the highest weightage is actually of, can you guys guess, conceptual or numerical? Which one should have the highest weightage? Yep. No, 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 it's not conceptual. It's numerical. Numerical has weightage of around 35 to 38 marks. Almost 50%. In fact, more than 50% of the paper is going to be numerical based. So this is what we need to focus on definitely this year. Numerical portions we should prepare for very, very thoroughly. Just remembering theory might be sufficient to pass us in the exam. But if you are looking for a top score, certainly above 80, 90, 95 in that range, then basically you need to go for conceptual part also very, very properly. Around 25, I could find 25 marks of conceptual things. Acha, in your exam, acha, in your schools, they ask 10% as numerical, or then it's bad, because that is not going to help you. Like you should basically talk to your school teachers that numericals need to be given more weightage now. Half of the paper is going to be numerical. Okay. So let us start with this paper's analysis in detail. So as you can see, the first question is mostly a conceptual question. I would not qualify it as a numerical question. It's basically given that the charges are attracting. So what should be the nature? See, they say Q1, Q2 is greater than 0, Q1, Q2 lesser than 0, Q1, Q2 equal to 0, and all this stuff. Does not make any sense. Basically, they are trying to say if two charges are getting multiplied and the product is positive, it means they are of same sign. So they're asking if they're attracting, are they of same sign, or their product is negative? Are they of different sign? And equal to 0 means one of them is, at least one of them is 0. So which one should it be? Come on, such an easy question. If they're attracting, it should be same sign. That is how simple it is. That is why I classify it as a conceptual question mostly. Little bit of math has been used, but not that great. Second question, as you can see again, as I mentioned, like electrostatics, or you can say electric field and electrostatic potential as highest weightage. If I just tell you, actually in total 4 marks of questions have been asked from electrostatic potential part. So this is one of them, the 1 mark question out of those 4, where they talk about electric dipoles, electric potential on the axis of this. So basically, you remember the concept. There's a negative charge, there's a positive charge. So they're asking the potential due to it. Like if you can see over here, they're asking what is the electrostatic potential if at a distance r its potential is v, then what is it going to be on an equatorial line. Now all this information is useless. Why is that so? What is the potential on this equatorial line due to both these charges? Let me take any point over here, p. Since it is at equal distance from here also, whatever negative potential it produces, same positive potential it produces while being at same distance. So basically this turns out to be 0. Fourth is the correct answer. You guys get it? Then look at the third question. Third question is mostly like conceptual, as you can clearly see. They are talking about time dependence of resistivity of the material. Now there's a simple thing. They are saying resistivity decreases with time, or does it increase with time? And options is given: copper, germanium, nichrome, germanium, and that's it. These are the 3 materials that they talk about: copper, germanium, and nichrome. So they're asking what is the relation. So it is just a theoretical question, as I said, because it's a fact, as you must have studied in current electricity chapter, that conductor's resistivity of a conductor increases with temperature. With temperature. In fact, you must have seen this relation also. Resistance of a conductor is R naught 1 plus alpha delta T. So it increases with temperature. And you will study it in semiconductors, but you can note it already that resistivity of a semiconductor, on the other hand, reduces with temperature. So basically the answer is option second, because material A is germanium because its resistivity reduces, and for conductor it increases. That's it. Then comes the main part, which we should be concerned about: numericals. So see, the first question is basically a numerical from the chapter moving charges and magnetism. It's not a difficult question at all. It's very easy. You can find similar questions in NCERT also, in the illustrations, in the examples, and in back exercises also. They have mentioned a couple of questions like this. They are talking about concentric and coplanar circular loops. So you can do this question where they are asking the magnetic field to be 0 at the common center. What must be the condition for the current? As simple as that. What you have to do is just use the relation that if current is I in a loop of radius r, what is going to be the magnetic field, guys? Can you tell me in chat? What is the magnetic field due to a current carrying wire, or I should say current carrying circular loop at the center of it? Now those who must have joined through phone must be wondering like, how are we going to even type all this? But if you guys have joined through a PC or a laptop, it should be easy for you to type. So if you remember, because of an infinitely long current carrying straight wire, which is on which this question has not been asked, there the magnetic field is mu naught I by 2 pi r. But if you talk about this question where a circular loop is given, there it's mu naught I by 2 r. So this relation we are supposed to use because of due to two wires, and then you can get the answer easily. So this was one of the numerical problems. Then after that, now you see the next question that they've asked is on the same thing, straight current carrying wire. So they are saying there's a straight current carrying wire carrying current I like this. And they're asking, they have given the cross sectional area also. It's given that it is having a cross sectional area of radius A and carries a steady current I. We have been asked, oh, it's given that current is uniformly distributed. So we have been asked the ratio of magnitudes of magnetic field at a distance A by 2 above the surface of the wire to a point at a distance A by 2 below its surface. Basically, they're asking magnetic fields ratio at this point A at a distance A by 2 outside it and at a distance at a point B at a depth A by 2. So outside seems very easy, right? Outside, basically at A point, you can say magnetic field is what? Outside, if I talk about, let me draw the cross-sectional view of it. Since it's an MCQ, we don't worry a lot about uh, like writing each and every step. We just need to solve the question very, very quickly and get 1 mark for it. If I take this point A, at what distance is it from the center of this wire? It's given radius is A. And this point A is at a further distance A by 2 outside it. So what is the distance between point A and the center? A by 2 plus A, right? It's going to be A plus A by 2. That's 3A by 2. So when you find magnetic field at A, it's going to be mu naught I divided by 2 pi into distance R. Distance radius is 3A by 2. But guys, when you talk about the point inside, that is going to be interesting. How would you find the magnetic field at a depth A by 2 inside it? This magnetic field at point B. What concept? In fact, B becomes a bit confusing to use because B stands for magnetic field also and this point also. Let me call this point as C. Let's change its name from B to C. So what is going to be magnetic field at point C? How would we find it? We are going to find it using Ampere's law. So that law is to be used here to get this answer. So you see, one of the parts was using the formula mu naught I by 2 pi r. Other was using the Ampere's law. For this, you will have to find the current enclosed in this circle of radius A by 2 and then go about solving it. So again, like two small questions in the single question, and then you get 1 mark. That is what makes it a bit tricky. But try to notice, like over here, you don't, these questions, they are not going to ask again, of course. They have already mentioned it in sample question paper. Our aim should be to note what all concepts they have given here and ensure that those concepts we can use properly. What are the concepts that we have used here? First of all, the formula in the previous question, fourth question, mu naught I by 2r. The next formula, mu naught I by 2 pi r, when it's a straight wire and we take magnetic field outside it. But inside it, we need to use the Ampere's law and then get the answer. So these are the small things that we are going to note and ensure that we know these things before going for the board exam this year. Then conceptual question from magnetism and matter chapter. If magnetizing field on a ferromagnetic material is increased, then what happens to its uh, permeability? So conceptual question, you can check it is going to decrease. You can think about all these reasons. Everything is given in NCERT for all these things. Conceptual question here. Look at the next one. It is a question based on, iron core coil is connected in series with electric bulb with an AC source. So it's a question on AC source as we see. And they're asking if this iron piece is taken out, like this, inside this solenoid, there's an iron piece. So it's not a straightforward question, not a classic board type of question, a little bit trick they have introduced over here. They have taken an iron piece and they have taken out the iron piece from it. So what happens when iron piece is drawn out of a solenoid? When iron is drawn out of solenoid, what difference does it bring to our math of AC circuits? If iron is drawn out of solenoid, what can we claim about it? Correct, Niranjan. Acha, sorry, you're giving the answer for the previous. Acha, increase. Okay, you're giving me the answer for it. But what happens when iron is drawn out of the solenoid? What exactly will happen in that case? Guys, inductance, if you remember, of a solenoid is what? Inductance of solenoid depends upon the permeability of the medium. Like if it's a number of turns of it is n, length is l, thin solenoid, radius r, then in that case, in self-inductance is given by relation. And you should not just by heart it. No, Ranjan. You should not just by heart it. You should actually learn how to derive it also. It's going to be like, you might know flux, magnetic flux, you have to represent as L into I. When you write the flux, then you get this expression. Basically, it turns out to be something like this. Mu n square, sorry, mu n square into L into pi r square, something like this you get. This is the self-inductance. The point here is that self-inductance is proportional to permeability. Like how much probability is present in the medium. Now tell me, if iron core is removed from the solenoid, what will happen to the self-inductance? Self-inductance increases or decreases? Now think over it, Ranjan. Isn't it going to decrease? If the iron is drawn out, permeability is going to decrease because iron gives its own permeability a little bit to it. So like what is iron? Ferromagnetic material. It basically magnetizes to increase the magnetization. So self-inductance is going to decrease in this case. And if the self-inductance decreases, you can imagine the reactance of the inductor, which is omega into L. This also is going to reduce. And then you can do the math and find out if this current, brightness of bulb depends upon what? Brightness of bulb depends upon current. Here the question is, will the current increase or decrease? You might remember this, that current is, the peak value of current is going to be peak value of voltage root of R square plus omega L square. So all these things you can think over and see if this current is going to increase or decrease. That is up to you then. Okay, so you would find out it's going to increase and all. Then you see the next question, wave optic. Sorry, this electromagnetic waves. Now, electromagnetic waves is not a very, very highly weighted chapter, but still let me mention 3 marks of question in total have been asked from it. Let me write it over here. From electromagnetic waves, 3 marks worth of questions have been asked. Let's see what kind of questions they are. This is the first one. In fact, this question itself contains 4 small different questions in it. So, and all of these are very, very basic things about them. So we have to just figure out which one is not true. These waves do not travel in material medium. Oh, that is true. Its electromagnetic wave does not need medium to travel. Electric and magnetic field attain maxima and minima at the same time. Yes. If you remember, electric and magnetic field are in same phase. If, for example, electric field reaches maximum, at the same point, magnetic field will reach maximum. And whenever electric field becomes zero, magnetic field becomes zero. So second statement also is true. Third statement it says is energy of electromagnetic wave is equally divided among electric and magnetic fields. That also is true. If you remember, energy density, energy per unit volume. Let me write. Energy density is defined as energy per unit volume. Now, energy density in electric field, in form of electric field, how much energy per unit volume is there? Half epsilon naught E square. Or you should say actually epsilon. If it's a medium, then also we should define it. It's epsilon into E square. And in terms of, in form of magnetic field, it's B square by 2 mu. Now, if you do the math and you use the 2 more formulae, these are these two relations that we have. And if you use just 2 more formulae, remember, this can be a question based on derivation also. They might ask you to prove that energy density of electric field and energy density of magnetic field are equal. How are we going to do this? We will write these 2 equations. Let's call them 1 and 2. And 2 more equations we will use. We will say third equation is magnitude of the electric field, amplitude of electric field is speed of light times the magnetic field in that medium. I'm not writing C because it can be in any medium. And fourth equation you use is speed of light in any medium is going to be 1 upon mu epsilon. When you use all these 4, you figure out that these things are actually equal. Energy density is same. So yes, energy is equally divided. C also is correct. So of course D is wrong. The fourth part is wrong. Why fourth part is wrong? Are the electric and magnetic fields parallel? No, as you can clearly see, they are perpendicular. So fourth will be the correct answer in this case. Okay, so these kind of questions, you like if you just clarify before the exam these 4 points, believe me, like most of the electromagnetic waves chapter will be done through it. All you need to do rest is write the equations of the waves, nothing else. So next up is this question, square rectangle loop. Yeah, it is basically an electromagnetic induction. Now, yes, another favorite topic. I think I've mentioned this, or I think I've not. Electromagnetic waves. Its weightage is actually one of the lengthiest chapter, but its weightage is comparatively lower compared to its length. Its total 5 marks of question were asked, and 1 mark worth question is present here. We can look at this. So here they are saying that there's a square, rectangular, circular, and elliptical loop. Basically, 4 shaped loops are there, and they're moving out of a uniform magnetic field. It's something like this. There's magnetic field here. So all these 4 loops are passing through it. What are the shapes? Let me check them again. Rectangular, square, circular, and elliptical. So they're asking when it moves towards right, like they're pulled in or pulled out, something is given. In which one of them induced EMF is not constant? In which one of them induced current or induced voltage will keep on varying with time? In which of the cases, like what does induced EMF even depend upon? Induced EMF is rate of change of magnetic flux. Flux is what? Magnetic field into change in area. You know, in this case, magnetic field is same. Area that this loop is exposed, like the area of this loop exposed to magnetic field, that is changing. So here, if you notice, if a rectangular loop or a square loop enters it, it is going to enter at constant rate. If earlier in first 1 second, 1 meter square goes in the next 1 second also 1 meter square will go in. That is why the rate of change of area is same in both of them as they enter. Here the rate of change of area is same, constant. So here it's constant. But the problem with circular and elliptical is that it's going to vary as it enters. Like imagine when the circle is partially entered, this much is the area. But then as it enters more, can you see that the width of the part also entering inside it has increased? So faster area will change through it. As it enters, the rate of increase of area is also not constant. It is going to vary in both of them. So here it's not constant. That is why circular and elliptical loops will be the correct answer. Here it is not constant. Okay, so don't need to worry about understanding all this stuff right now. We are just analyzing. I'm just trying to give you a feeling what kind of questions they're asking here. What is the depth to which we should think about these concepts from board exams perspective? Then there's a question from wave optics. I don't know if you guys have even studied it till now, but let me just mention wave optics also had a little bit weightage. 6 marks of questions were asked, as I had mentioned earlier here. 6 mark worth of questions were asked. If you're still to learn it, then guys, please focus that wave optics you understand very, very properly. After your wave optics, the next is photoelectric effect. Now, photoelectric effect is also one of the concepts. Now, I believe, like in my opinion, photoelectric effect is the chapter that you should study with most energy, like spending most time in. The reason is it is a small chapter. It is just a concept, one small concept. And how many marks worth of questions? 5 marks worth of questions. Just try to compare it with these chapters. In electric field and charges, you are going to study a lot and lot of stuff. For how many marks? 8 marks. Electrostatic potential, so much stuff. 4 marks only. EMI, so much to cover. 5 marks. But photoelectric effect is a single concept. And just on the basis of that, you can get 5 marks. So this is something we should definitely ensure that we understand everything about it. So photoelectric effect, I would say, is our favorite chapter of this year. Highest weightage questions are being asked relative to the amount of time you need to spend on it. Okay, we will see. There's one more chapter like that. We are going to come to that in a while. But yeah, photoelectric effect for now should be noted is important. The other chapter that I was talking about is also important, is atomic physics. The thing with atomic physics is it's not very, very small. There are a couple of concepts involved in quite a few of them. But most of this chapter you have studied in class 11th chemistry already. You know about Bohr's model of atom. You do know about electronics transition. You know Balmer, Paschen, bracket, fund, everything. So most of this chapter you already know. So something that you already know from last year, you are getting 6 marks worth of question for it. So this makes us our second favorite of this paper. Okay, so atomic physics also, and I think you guys can even solve this question. You might already know if you have not even studied in physics this year. Mostly like a grade 11th chemistry question. And if you're preparing for competitive exams like JEE NEET, then you must have realized you are already studying this chapter because 11th chapters will also be asked in JEE and NEET. So you're already prepared for it. So probably you don't even need to study this chapter separately in physics. Then another all-time favorite chapter in competitive exams also and CBSE also is nuclear force, nuclear physics. A theoretical question on nuclear physics, when you study it, you will realize it's easy question. It's a very easy question. You can just look at the options and mark it. Not going to discuss it here, but yeah, it's an easy question. So nuclear physics, let me tell you, total 3 marks of questions have been asked. I think compared to the length of the chapter, this 3 mark is completely justified. So does not take a lot of time to study nuclear physics, but yeah, 3 marks of question is also not too much. So that's fine. Something that we should focus on, nuclear physics. Okay. Then another concept is again on AC. Now see, AC, the second question has been asked in this MCQ itself. So let me tell you, from this chapter, in total 5 marks of questions have been asked from AC circuits. So this again makes this topic also important. Although like AC, some people find a little bit difficult to understand, but believe me, you have a lot of time right now. If you focus a little bit on it, practice it, get your doubts cleared from your faculties, then AC is something also which is high weightage. You can focus and get a lot of marks in. Okay, so yeah, I agree. AC is a little difficult to understand, but you can actually do it because in the end, if it's in grade 12th, it is definitely doable by you guys. So try to work on AC because as I said, a little difficult, but a lot of marks questions have been asked. We should focus on it. Hmm. You can try this question. Then you can see this next question is from electrostatic potential and capacitance. Basically the potential part, numerical. I told you many numericals have been asked. Then yes, 3 interesting assertion reasoning type questions have been asked. Question 16, 17, 18 are assertion reasoning type. You would always notice that assertion reasoning type of questions are mostly asked from theoretical type of conceptual type of questions because there is a concept, there's an assertion on the basis of that, they ask the reason behind it, if it is there or not. You must be accustomed to this kind of questions because in 10th board exams also you must have seen these kind of questions. A, both assertion reasoning are correct and R is the correct explanation of it. Second, you select B if it is not the correct explanation. If first one is right, second one is wrong, you choose option C. If first one is wrong, second one is right, you choose option D. So you can see from semiconductor, one conceptual question, then from wave optics, conceptual question, and then from photoelectric effect, conceptual question. All 3 chapters you are still to do. So again, increases its weightage. Let me mention about semiconductors chapter. I think I have not mentioned it till now. No, I have mentioned 7 marks in total. So yeah, semiconductors is also an important chapter. 7 whole marks, very, very important. Then let's take a quick look at the section B, where 2 marks of questions have been asked. You need to write the answers, not very long answers. Mostly you have to write the answers only. A little bit of explanation wherever like you need to, if there's a principle used, you can mention the principle. If there is some small logic, you can mention the logic. So you see the first question is from electromagnetic waves. Very, very theoretical chapter. Just theory kind of things are there. You need to by heart in this. What wave is used for radar systems? What is used to kill germs in water purifiers? What is used in uh, to improve visibility of fog, like during fog and mist conditions? Simple stuff. You can go through it. Another question, magnetism matter. Again, conceptual question. So there are quite a few conceptual questions here, but we will see like in this section, you would see conceptual questions. Later on, there will be mostly numerical ones. So in this, basically they're asking based on the field lines, you have to guess which one is ferromagnetic, which one is paramagnetic. So that is easy. Something which is repelling is dia. Which one is attracting is para. Nothing is getting highly magnetized, so no ferro over here. Then two choices have been given from nuclear physics and atomic physics. Doable question. You when you would study it, this chapter, you would realize it's a simple formula on which it is based. R equals to R naught, a to the power 1 by 3. You can do this question mostly verbally also. Okay, so it's also an easy question. From these two chapters, options have been given. Now an interesting question. They say they have taken a transparent material. It's a question from ray optics. Let me mention that. They are saying they have taken a biconvex lens of focal length of refractive index 1.25. But they have dipped it in water. Water has refractive index 1.33. We might know that already. So now they're asking, will it behave like a converging lens or a diverging lens? We might wonder, like, why are they even asking it? Convex lens is always converging, but actually that's not true. It depends upon the refractive indices of the material and the surrounding. Here, when you do the calculation, when you use the lens maker's formula, point worth noting, lens maker formula question is being asked. So in that case, you would find focal length is lesser than 0, negative. It actually turns out to be a diverging lens. Then that is fine. 1 mark for that. But one another mark for justifying the answer. How would you justify the answer? That is the most important question we face trouble in. Like we always get the answer. We get okay, F is negative, so it's diverging lens. But what do they mean by justifying the answer? Should our justification be this is what we got mathematically? You can do that, but additionally, always guys, to support your answer, draw a ray diagram. That is what my suggestion is. Draw this convex lens, draw the rays of light coming from infinity. You are supposed to prove its focal length is negative. It is a diverging lens. Do one thing, show them why it is happening that way. Draw normals. So what do you think? If it's moving from outside denser to inside rarer medium, should it bend towards the normal or away from the normal? A ray of light moving from outside denser to inside rarer is going to bend towards the normal or away from the normal? What do you guys think? Away from the normal, correct. See, here it's going to bend, like it's not going to pass straight, it's going to bend away from the normal upward, like this. And then again, when you draw the normal, it's going to bend towards the, drawn the other way around, I'm so sorry. When you again draw the normal, you're going to say it's going to bend towards the normal. So see, it bends away only every time, sorry, like this. It basically is acting like a diverging lens. The beam of light got diverged. So that is also how you can justify your answer. The next question is on semiconductor, 2 mark question. Okay, so you're going to see this when you study this chapter. Then another question from wave optics, numerical based. So previous one also is like this is mostly conceptual, but this one is wave optics is numerical based question. Then after that you have a question from it's photoelectric effect. No, sorry. It is from electric fields and charges, electric charges and fields. If you see what they mention here is they try to kind of make a capacitor. They take two thin metal parallel plates and they give first one a positive charge density sigma, another one negative charge density minus sigma. So sigma's value is given. One is positive, other is negative. They are asking electric field in the three regions, in the two regions, over here in region A and in the region B. So what formula are we going to use here? The simple formula that if there is a charge sheet, for example, this green charge, it is going to produce electric field sigma upon 2 epsilon naught at this point. And this yellow negative charge pulls electric field. It's going to pull it downward sigma upon 2 epsilon naught. So outside it will be 0. So this formula basically is to be used, just mentioning the formula. Electric field due to a charge sheet is sigma upon 2 epsilon naught. This is on which this question has been based. Okay. Then moving to like more highly weighted topics. Section C we have here. Where did it go? Yeah, over here. Section C. Now, as we proceed to further sections, lesser and lesser number of questions and more marks we are moving to. So section C, each of the question is of 3 mark. So here we are moving to the derivation kind of questions. So see over here, they are already asking us to obtain an expression of this force. What force? Basically, they are saying two conducting wires carrying current in different direction or same direction. Same direction. So I1 current like this, I2 current like this. So they are asking you to find the force acting on them. Like these are going to attract or repel. If you guys have studied this, you would find that these are attracted towards each other by equal forces. So you have to obtain the expression of this force and define 1 ampere. Oh, it's a very common question. Like even if they don't ask it as a 3 mark question, they might ask it as a 2 mark question also to define 1 ampere and get it. So this makes it an important kind of question. But this is one of those few derivation based questions that have been asked. I mentioned derivations are few this time. So this is one of them. Then they're asking the next question is based on I think this is based on electromagnetic induction. Yes, they're talking about induced current. So if you notice, whenever they're asking you to draw a graph of magnetic field versus T, that is given. You are supposed to find the graph of a variation of current as a function of time. So basically it is based on the formula of Faraday's law. Faraday's law, if you remember, induced EMF is rate of change of magnetic flux dV by dt. And once you get induced EMF, you can find the induced current by dividing it by resistance. Induced EMF divided by resistance. This will give you the answer. So it's mostly about finding the slope of this and all. Okay, so you can do this question. I would say not a very easy question, but not a difficult question also. The only thing is you need to analyze this graph and get the rate of change of this magnetic flux. That's it. Okay, so this was from electromagnetic induction. Then after that, see, again, we came over AC. I told you, little tricky to understand, but once you start understanding it, a lot of marks you will gain. Okay, here also you have to get some expression of current through a purely capacitive circuit. Okay, so they have given this purely capacitive circuit C, and EMF they have given as, voltage they have given as E naught sine omega t. They are asking you to find the expression of current. Very common question. One of the first things that you learn, easy question from AC, you can do it easily. And there's another part which you also can check. It's also not that difficult, but had I been given the option, I would go for this because this is something that we study for in the very first class of AC current. So that would always be my choice. So AC current. Then after that, we also have a photoelectric effect. Again, photoelectric effect. Conceptual question, you can do it. You will realize it's not that difficult question when you study it. This is the bit tricky part. I noticed one thing about this paper. Whenever they give choices, they give the options. These are not equally weighted options because first part is easy. First of the option is easy, but other one is not that easy. It's a moderate level question. So there's significant difference between the two options. So I feel like this is kind of a mistake that these guys have made while releasing the sample question paper. I hope the same thing is not there in the board exam. But anyways, you should always know what question they have asked in this other optional also, because in the exam you don't know if question will be asked from this section or this section. You, by looking at the sample question paper, should be able to solve all the questions. And again, one question from photoelectric effect. Like it's a mixed question actually. First of all, they talk about atomic physics, and then they mix it to find the threshold wavelength of the material. So atomic physics plus photoelectric effect, a mixed question that I would say makes it a little difficult question with some difficult or hard to deal with values also in the question, minus 13.6 and 1, 2, 3. Generally, like in these questions, decimal places we need to get right. So if you are just comfortable with it, if you have practiced a little bit questions, like if you have practiced these kind of questions from the NCRT, from exemplars, and also if you have some reference book, all the questions of photoelectric effect and atomic physics, then these questions will also be not very difficult to deal with. But do one thing at the end of the paper, always cross check your calculation for these questions first before submitting. This is the important part. And now moving to the second last section, the 5 marks questions. Highest weighted questions are present in this section. And you can even see the length of these questions, like how many parts are there? A part, then B part. A itself had part 1 and 2. B itself had part 1, 2, 3. But I am not very much afraid of it because I clearly see it's like having 2 different questions here. One is a different question altogether related to electrostatic potential, like a 2-mark question. And then starts another 3-mark question based on capacitor. The only question that I saw from capacitor in this whole test, in this whole question paper. So capacitor seems to have a little lower weightage in this, but still I would say let's not uh, underestimate it. Although like questions can be less, but it's easy to understand if you understand this all these parts. It's like they have tried to cover everything that they ask questions from this chapter. So if you're clear with all these parts, all these 3 parts, then you are done with capacitor. Of course, study a bit more, but these are the most important things that they have asked. And in the options, you would see they have given 1 numerical, 1 derivation, and then 1 conceptual question, like kind of derivation plus conceptual. So again, as I said, uh, the distribution is not equal. This is mostly like an easy question, a little lengthy though, but this is a lengthy, and for some people it can be a bit difficult question also, those who are not very much comfortable with derivations and all. So okay, that is an observation that we had. Other long question is one from current electricity over here. Options are given. Here it's from current electricity. Again, conceptual question from current electricity. Defining drift velocity and all, getting the expression of it, all that stuff. Conceptual plus derivation. Derivations are mostly asked in the section D only. 5-mark question, sometimes 3-mark question, but not before that. And then in this, they're asking the combination of EMF, combination of cell topic, combination of cells. If you remember, there were 2 formulae. If resistors are if the batteries are in series, then the equivalent EMF is E1 plus E2 plus E3 and so on. Equivalent resistance is R1 plus R2 plus R3 and so on. That is one concept, one formula in this topic. Other formula is for parallel combination. For parallel, you can say equivalent EMF is, this is a bit tricky to remember, but if you practice it a number of times, then you by heart it. Like my belief is like whenever there's something that you need to by heart, any formula, just practice it 5, 6, 7 times. You would realize if you apply it a number of times, it gets learned by itself. So equivalent EMF is this. And then equivalent resistance in this case is that classic formula of parallel circuit. 1 upon R equivalent is 1 by R1 plus 1 by R2 plus 1 by R3 and so on. So these formulae, on the basis of this, which you can get it, or there's a part given in, there's an option given in this stating the 2 Kirchhoff's laws and then deriving an equation for balanced Wheatstone bridge using Kirchhoff's laws, using KVL. This is a lengthy derivation. But that is the good thing about lengthy derivations. If we study it properly, if we prepare the lengthy derivations, and if by chance a question comes, which I believe this kind of question actually can come, because like it is one of the few derivations that are there from this chapter. So I strongly recommend that you study this derivation properly. If not for your board exam, at least in some of your school upcoming exams, this question will definitely be asked to derive the equation of balanced Wheatstone bridge using KVL. Using Kirchhoff's laws, basically KVL mostly. KCL is also used in one of the steps. So lengthy derivation, but if you solve it, if you do this, you get 3 marks straight for it. So I would recommend you to go for it. Mostly a conceptual plus derivation question in option. And then this last question of section D, one is on wave optics, other is from ray optics. Most, like I would say, moderate level questions, not difficult, but not very easy also. And similarly, this in the options they have given one wave optics question, again one ray optic question of same difficulty level. So here I found the level of both the parts same. You can go through them, practice them before your exam, and similar questions on Prism. And then finally, the case study type of questions. I told you there will be a number of parts in case study questions. See, 1, 2, 3, and between this and this option has been given in the third part also. This you can solve conceptual question. This is a bit tricky. Like not tricky. It's like if you understand the theory, like this answer to this question, you would not straight find in any book. Like not in any book, I should say. You won't find it straight in NCRT at least. But if you understand the other topics like aberration, then you will be able to understand, you will be able to guess, think by yourself why they would require multi-component lenses in both objective and eyepiece of a microscope. I don't know how many of you have already studied microscope, telescope, but yes, the point is to get the answer to these kind of questions, you should properly understand the theory in the book. Now, if you guys follow NCRT, great, follow it. There you will be able to find these small points. But even if you don't, if you're following some other refresher, some other book, if you're in a coaching following the reference book, then also it's fine. You will be able to find answer to all these questions over there. Like you're getting my point. Like you won't find this directly in that topic. And see, it's not a very highly weighted question. I think it should be a question of 1 mark or so. They don't want to like put at stake a lot of marks of yours to think something out of the box. Although this is how it should be, but they still don't do it because they want you to score a lot. So 1 mark question, which I would say is kind of the most difficult for you because conceptual it is, but you need to think by yourself. It's not straight given in the book. And then write to the point difference between compound microscope and astrometric telescope. Very easy to do. Okay, you would find it easily in your class notes also, from your school notes also, from an NCRT also. Every easily you can write this point. So as I said, case-based questions are easy. One of these questions came a little difficult, but otherwise is easy. So this first case-based question was from uh, ray optics, and the next case-based question is from semiconductors, the last question of this paper. As I told you, semiconductors turned out to be one of the most highly weighted chapters. Most of the chapters we have are going to come later, but all these are conceptual questions from book. Even if I don't read this passage, I will be able to solve all these questions. I don't know why they even give case-based questions. It seems as if you need to study the case and then answer it. You don't need to answer it. In fact, in the previous question also, you don't need to read all this to answer these 3 questions. You can solve them without reading them also. Simple logic, either like logic based questions or something which is given in the book already. So why LEDs are made of compound semiconductor? You would know the answer of it when you study it. Band gap of LED order, you would study that. Circuit solving, you will easily study. VI characteristics of PN junction, you study it. So never get scared of case-based questions. Easy 4-mark question. These are case-based questions, easy to get score in. I used to be most relieved when I was in my 12th, whenever case-based questions were asked, because mostly they were so easy. Particularly when you have solved 5-mark questions, these seem like a cake. So that is my analysis, guys. As I said, a lot of focus around more than 50%, around 50%, more than 50% numericals. So there is something that you cannot escape. Derivations. Okay. After that, conceptual, you should definitely focus on. Conceptual based questions are also there. But if you're looking for a top score, and so you cannot even let go derivations, which are having 8 to 10 marks of weightage. Okay. And as a last reminder, a lot of marks in the upcoming topics in your school. So if you have not focused on these properly, of course, you're going to do that during the revision time. But this is right time to start a serious preparation now onwards to score in these topics and get a very good score in board exams. So that will be it for my analysis of this paper. And never read, you don't need to. Great. So in fact, in your board exam also, you don't need to read the case study. Without that, just read the questions, you'll be able to solve them, Niranjan. Fine, guys. See you later then. Now this analysis over. Let's see when the dates of the board exams are, like the exact papers are released, and the exact timetable, I mean. And then accordingly, we are going to run a series in future to help you with like the last minute tips, preparation, important questions, all these things also we are going to see. Okay, see you then, guys. Bye bye.